Welcome to section 5.6. In this section we're going to be looking at parallel and perpendicular lines. In the first section here we're going to just look at parallel lines. Let's take a look at a warm-up here. What I want you to do is I want you to graph the line y equals 2x minus 4, and then I want you to put that same equation y equals 2x minus 4 in standard form. Let's see how you did. The equation 2x minus 4 is in slope-intercept form. So we graph the y-intercept first. So we go down to -4 on the y-axis and put a dot. From there, since the slope is positive 2, we move up 2 and over 1 and connect our dots. To put this in standard form, remember standard form is ax plus by equals c. A cannot be negative and there cannot be any fractions or decimals. So first thing we need to do is subtract 2x from both sides of our equation. We now have a -2x plus y equals a -4. Since the negative cannot be out front, we have to multiply everything by a -1. So positive 2x minus y equals positive 4. Our vocabulary word for this part of the section is parallel, and parallel lines are lines that are in the same plane but never intersect. When you get to geometry next year, you'll use this symbol here that kind of looks like two straight lines. That is the symbol for parallel. Take a look at these three pictures and see if you can find any parallel lines. I've highlighted a couple here in red. The tracks here in between are parallel. These lines here are parallel. The lines on the road are parallel, and these lines on the road are parallel. You may have found more, but those are the ones that I've highlighted. Let's take a look at these lines that I've graphed for you. I want you to think of some similarities and some differences that you see in these lines. Here are some of the similarities and differences that I came up with. The similarities, they all have the same slope. They're all lines, they're all linear, and they're all increasing. Some differences, they have a different y-intercept, and they're in a different position on the grid. Take a look at our key concept for slopes of parallel lines. It says non-vertical lines are parallel if they have the same slope and different y-intercepts. Vertical lines are parallel if they have different x-intercepts. So let's take a look at our problem here. It says to draw a line from each equation in column A to an equation whose graph is parallel in column B. Since we want parallel lines, we want the slopes to be the same. You notice here that we have our equations written in slope-intercept form, so it's very easy to pick out our slope. So go ahead and match them up and we'll see how you do. The first one here has a slope of 2, so we're looking for the equation in column B that also has a slope of 2, and it's this middle one. The next equation here has a slope of 1/3, so we're looking for an equation in the second column that has a slope of 1/3, and it's the last one. And this last equation is a vertical line, so I'm looking for another vertical line, and that's the first equation. Okay, so what are we going to be doing for our homework assignment? Well, we're going to be writing equations of lines that are parallel to a given line going through a particular point. So let's look at an example. It says a line passes through the point -3, -1, and is parallel to the graph of y equals 2x plus 3. So it says find the equation that represents the line in slope-intercept form. So first thing you need to do is figure out the slope of the given line. So the given line was 2x plus 3. It's in slope-intercept form, so it's easy to see that our slope is 2. The slope of any line parallel to the graph is going to have the same slope, so that slope's also going to be 2. And now, since we have a slope and we have a point, we use point-slope form to come up with the equation. So we have y minus a -1 equals 2 times x minus a -3. We fix our double negatives here, so we now have y plus 1 equals 2 times the quantity x plus 3. Then we distribute, so we have our 2 to our x and our 2 to our 3, so 2x plus 6. Subtract 1 from both sides because in the directions they wanted this in slope-intercept form. So we subtract 1 from both sides, so you have y equals 2x plus 5. Here's another example. We're still writing an equation that's parallel. We have our point that they've given us and our equation that they've given us. This time they've given us an equation in point-slope form. So again, it's easy to pick out our slope. Here it's -1. Since we want a line parallel, we want the same slope going through this point. So we have our x1 and our y1 and our m. Again, using our point slope form, we have y minus a negative 2 equals negative 1 times the quantity x minus 1. Distribute the negative 1. So we have y, and fix the double negative here. So we have y plus 2 equals negative x plus 1. Subtract 2 from both sides to get this in slope-intercept form. And now we end up with y equals a negative x minus 1. Another example here. Notice this time we have y equals 2. What kind of a line would that be? Well, if we take a look at our grid here, we don't have any x's. We know that this is y equals 2, so we would come up 2 on our grid and draw a horizontal line. Now what's going to be parallel to this? Well, another horizontal line. We know that horizontal lines have slopes of 0. So using our point slope form, we have y minus 4 equals 0 for slope, x minus a negative 3. Fix the double negative here, so y minus 4 equals 0 times the quantity x plus 3. Y minus 4 equals 0x plus 0, also known as just 0. Add 4 to both sides, so we end up with y equals 4. Now the shortcut here, if you realize that this is a horizontal line, all you're going to need is this number from your point, because that's the point that we're going to pass through. So we're going to pass through the point negative 3, 4, which is right here on our grid. And in order to have a horizontal line, it's got to go through that point. So it's going to be y equals 4. Or you can go through the work. Either one would work. A final example here. We have our given equation y equals negative 2x plus 1 and our point. This time our equation's given to us in slope-intercept form, so we pick out our slope of negative 2. We use point slope form, so y minus a negative 1 equals negative 2 x minus 2. Fix the double negative and distribute. So we get y plus 1 equals negative 2x plus 4. We want this in slope-intercept form, so we subtract 1 from both sides to get y equals negative 2x plus 3. Your assignment for this section is on page 331, numbers 7 through 12.